Please welcome David Strom.
Thank you. Never have I been more relieved not to have relieved myself and skipped the break. So thanks, everybody. I want to take this a little bit more technical, and I'm not pushing anything here. I wanted to give you an idea of where we're going with security. I call it New Directions, Old Fears, and also give you some of my recommendations for some of the innovators that you won't see here today, but that you can find out about online. And my background, I went to that junior university down the road in Palo Alto. Back when I went there, the Terman building was just being finished. It's kind of upsetting to me to see that it's no longer in existence. Such is life in California. I got a degree in operations research, which is actually very prescient in terms of understanding mathematical models and building the kinds of structures that underlie machine learning and AI. And the typical AI process, as we all know by now, starts with building a data lake, collecting information, trying to suss out what's going on, in this case security events, and breach notifications, and then coming up with an algorithm and building your model and testing it and see what you got right, what you got wrong, and keep iterating until you can figure this out. So that's great, except we have too much data, unfortunately, when it comes to security. We can log everything, and how do we know that that one particular packet that entered our network was the one that was entered by an adversary and not by a legitimate user? So it's a lot harder to figure this stuff out, and it's a lot harder to use your hands-on experience and intuition in ways to really give you an idea about the data. So we'll talk a little bit about Skynet, because everybody has to mention that in an AI presentation, the current malware situation that we have, some issues with various AI security implementations, and then I'll give you some hopes for the future in some of these case studies. So this is usually the image that comes to mind when we think about machine learning and how the machines are going to take over the world and eliminate humankind. I actually would say to that, hasta la vista, because it's really machines battling machines when we're talking about AI security things. We're trying to automate various ways to figure out what the machines are trying to automate around us. So let's just get rid of that mythology once and for all. The current malware situation is a lot like this diagram, what I call living off the land. And that is hackers and adversaries try to disguise what they're doing as normal processes in typically in the Windows operating system. So it's a PowerShell script, or if it's a command that's buried in the operating system, or adding a registry key. These aren't any unusual things until you see what's going on there and you see that they're leveraging those native processes to make things harder to detect and to cause mischief on our networks. So that's a very hard problem to solve, unfortunately. The second thing is what malware is getting better at targeting victims. It used to be that you would just spray it and pray for something to happen, and now it's more of targeting and staying inside a network. And we've had situations, there's news stories every week where malware has been living for years and just now been found out by an analyst. And these are some pretty impressive organizations. They're not some two-bit operations, but very large Fortune 100 and 500 companies that, oh my God, this thing is in our company, we got to get rid of it. And they don't know exactly how long it's been there, but they know it's been there far too long. So at the end of the day, malware is really about money, and it's about collecting money in any way that they can, and people are getting more and more efficient about doing that. And it used to be more of a nuisance back in the early days of PCs. Now it's become a big profit center, and we have people that are targeting specific revenue operations, ransomware, for example, a very profitable thing that can be done because a lot of companies will just pay it rather than try to figure out how to stop it. And a lot of nation states have gotten involved in this for the money. I mean, North Korea probably funds a good portion of its operations through malware now because they can't sell their products on open markets. So what's going on with the current state of the art? a friend of mine, Dudu Miram, who is the CTO of Deutsche Telekom Labs, talks about this cyber arms race, this machine versus machine kind of thing that's happening. Just as the defenders get better at figuring out what's going on, the attackers get better at hiding what's going on. So we keep going back and forth with this arms race. And AI might be able to help us out here, but the problem is picking the right time horizon. So if you pick too short of a time horizon, you'll miss the attack, and if you pick too long of a time horizon, you'll just get buried in data. So you've got to be very intelligent about that and understand how you build your model. And just so you remember how to build models, I've got the little diagram here just to keep you informed of that. The other problem is one of attribution. Most of us remember the WannaCry malware attack. Probably the first time a piece of malware was identified by the White House in public. And originally, the original researchers found a Chinese link inside the ransomware. And up until that point, most of the people thought, well, maybe it was China. It turns out it wasn't, it was North Korea. How did they figure that out? They looked at the metadata for the time zones that were used in the code, and North Korea has a time zone that's different from Beijing time, and that's how they figured it out. So little clues like that. You might not really catch it unless you're deep inside the code, and then they were able to link it up with the Sony attack and all the other rest of this history. So with a lot of cases, attackers put in false flags or false clues to deliberately try to mislead people because they don't want to be attributed to the creation of the malware because they're afraid they're going to get punished for it. So unfortunately, there's very little incentive from commercial businesses to figure this out. They just want to get rid of it. The other problem we have is that front-end developers are very busy people, and they usually don't think about security until after they've written the code or until after they have a problem with the code, which is oftentimes much too late. And we have to get better at putting in the implications, the security implications, as they're building the code right up front, so that when they're doing testing, they can understand what security situations will be triggered as a result of problems with their coding model. This is a typical view of what a security analyst sees on a day-to-day thing. It's a firewall policy screen, and businesses have hundreds, if not thousands, of these rule sets, and they're constantly tweaking these rules to improve their operations, to protect their networks, to screen things that are going through, or they get a call from a developer saying, can you please open up a port in the firewall so that our apps can talk to each other, and that was done to accommodate somebody, and then years later that port is still open even though that app has since died of natural causes. I see a few of you nodding in the audience. So it would be nice to use AI to automate some of these things so we don't have to depend on institutional memory or imperfect memories to prevent our networks from being attacked. What's interesting, though, is we're in this period of almost too many data models and too many sources. Amazon, Google, and now Azure all have machine learning products that are available on their infrastructure services. Microsoft just announced theirs a couple of weeks ago. For free, you can pretty much get an incredible set of tools to build your models and put your data in, and you really don't have to have any resources other than a web browser and a way to get the data up to them. There's things like forecasting, data analytics, image recognition, conversational interfaces, machine language training tools. I mean, these are pretty incredible things that you can have at your resources that years ago cost hundreds of thousands of dollars. So the cloud really has been kind to machine learning in that respect. It's just a matter of getting to learn how to use these very powerful tools. Okay, so I've talked enough about some of the problems. Let's talk about some of the innovations and how people are doing some interesting things with AI and security. So the first thing that I want to talk about is something called homomorphic encryption. Now, earlier, the gentleman from IBM mentioned how you don't want to necessarily have Bank of America mixing their data with, say, Morgan Stanley's data. You want to keep people's data separate. And this is an algorithm that's used, it's been around in academia for over a decade, that basically segregates data so that the encryption is applied selectively and that people, even if they intercept the information across the wire, can't necessarily decrypt it if they're not the intended recipient. There's a lot of mathematics. I don't even want to bore you with that details. I'm not sure I even understand it myself since my graduate days are long behind me. But there are a lot of companies that are using this. This one particular slide is from a company called Duality, and it's called Secure Plus. There's Unveil's Zero Reveal. Capnion has a product called Ghost PII, and Prevail has email and file security solutions. So there's a lot of activity in this space. There's a couple of open source projects such as OpenMind, M-I-N-E-D, and HELib. They also have tool sets that can use the homomorphic encryption technologies. So that's pretty cool. And another application of it is this San Diego effort called the Community Information Exchange. So the idea is a common trust broker that social service agencies can use to give out resources, food banks, healthcare, job assistance, that sort of stuff. You don't necessarily want those agencies to know what the other ones are doing as long as you can identify that it's the same individual that's getting the care. And so they use the encryption technologies to be able to deliver this. And I think there's about 25 agencies that are now part of this community exchange. It's pretty cool what's going on. Google has done a completely different approach, and they have an outfit that's called Chronicle that's been around for a little bit, and their first product is called Backstory. And the idea here is who has the most data on all of us? It's Google. And so they go in and they harvest all the network events that are happening to your particular business that they've collected over the years. I mean, we're talking going back decades. And then they comb through that and they look for that one security event that caused problems on your network. And it may have happened 3 years ago. And they can show you, here's that packet trace that came out, and it was because this guy from China, or a Chinese IP address, came in and monkeyed around with this Windows endpoint, and this is where your life started turning to being more miserable, and when you were first attacked. So it's a really interesting idea. It's not yet in production. They've tried it out in a few cases. They've had some spectacular successes because of their deep history of all this information. It's a little scary in how much they actually collect about us. I don't know how many of you have actually looked at your Google account and downloaded the information that they store on you. It's quite a dossier. And thankfully, there are ways that you can now restrict it. They're finally learning that there are people that actually want to do that. Another good example is in the Bitcoin world. So when I want to go and start a new account with a Bitcoin exchange, I have to prove that I am real, and the way to do that is to upload a copy of my driver's license or my passport or some other identity document. And you probably wouldn't be surprised that people upload fake IDs all the time in hopes of eluding actual their real identity. So the Coinbase folks wrote an anti-fraud system that basically compares the picture on the ID to see if it's been used already, the serial number or the birth date or some other statistics that are on that ID. They can go through the millions of stuff that they've already collected and see if there's a match that somebody just photoshopped in the picture or photoshopped in a name or whatever. So that's really interesting. And again, they're using Amazon's machine learning tools, so they didn't have to reinvent the wheel completely on this, and they were able to leverage a lot of the cloud technology to build this system. It's pretty impressive. Cyberix is a defense-sponsored entity, and they have a way they've built their own machine learning AI engine that basically ingests data and creates models and is specifically designed for security vulnerabilities. So again, they've taken a first stab at it, and they're beginning to use it in DoD to detect insider threats. As you can imagine, DoD's network is humongous. They have tons of contractors. They have lots of ways that people can penetrate that network. They get hit millions of times a second by hackers because it's such a rich target. This is a very pretty graph. It's from a company called Darktrace. And what the idea here is that we're using AI to do some threat hunting. So we go around, we look at all those nice traces, seeing what people are trying to enter our network, and do some real-time queries to see what's going on, if there's a problem, and to better visualize the attacks. So it's a nice, pretty map. It shows for a nice slide. It doesn't necessarily get to the power of AI, because one of the problems is to really interpret this map, you need to have a degree in security engineering to really understand what's going on. A much better situation would be to use AI so that all of us in the room who are not security professionals can figure this stuff out. And there are a number of vendors doing this besides Darktrace. Here's one of them. It's a company called Endgame. They're based here in San Francisco, just down the street. And they have both cloud and on-premises protection so that they can give you a better visualization of what's going on. They only go back 4 months in terms of data, but that's still pretty good compared to what a lot of their competitors do. Because again, you want to have some historical background to see what's going on. And they can basically get a holistic view of the infection, where it went from the initial entry point to how it infected other machines on your network. And like I said, it's very usable by the non-security staff. Okay, so we've gone full circle. We started at Terminator. We ended up here at Minority Report. This is actually reality. There's a company called Zero Eyes that's already using AI to look at images and determine if somebody's carrying a weapon on them as they enter a public space. So if that doesn't freak you out, I guess the next time you go to Cambridge and use a restroom, maybe you'll think about that. So we really aren't that far afield from Minority Report. I hope you've enjoyed this little tour. Be happy to take a few questions. Thank you very much for your time today.